Okay, for number 6, it's asking you to write the equation of a line that contains the points P and is parallel to line M. So the key for this is you need to know the slope of the line that they've given you, and you need to know the coordinate for the point that your equation or your line is supposed to be going through. So to start off, you need to find the slope of this line. Since they didn't give you the coordinates of the points, you can actually count the rise and the run to get the slope here. The easiest way to do it is to start with your pencils at this point, and then count your rise and your run till you get to another point on the line, which I'm going to choose this one. Right here. All right, so count the rise and the run of those points. If you start at the bottom, then count, you're going to rise 1, 2, 3 units, and then you're running 1 unit to the left. So if I rise 3 and I run 1 to the left, this line is going to have a slope of what? Let's try that again. What's the slope?
1/3.
What's the slope?
-3.
It's -3. 3 divided by -1 is a slope of -3. Now the key is they want us to give the equation of a line that's parallel to this one. So what do you know about lines that are parallel? What do you know about their slopes?
They're the same.
They're the same. So a line parallel to this is going to have a slope of -3 also. Okay? So the line they've given you has a slope of -3. A line parallel to it is also going to have a slope of -3. Is everybody clear on that?
Yes.
Right, parallel lines have the same slope. So now, the next thing you need is the point that you're supposed to go through. They've given you this supersized point. What is the coordinate for point P?
5, -2.
It's 3.
Let's start it again. What is it?
3,
Oh,
2.
three.
That's 3 is 12.
Okay, so it's 3, -2 is the coordinate for point P. Now, what you have to remember is this is going to be your X, this is going to be your Y, and then you're using the slope of -3. At this point, you're going to plug into the equation Y equals mx plus b.
So equals.
Y equals mx plus b. Now, if y is equal to mx plus b, and I substitute in what is y?
-2.
So I have -2 equals, what is my m? What is my x? X is 3
That was very easy.
plus b. Okay, so you have -2 equals -9 plus b. What do I do
Add
now?
9 on both sides.
Add 9 to both sides. So if I add 9, -2 plus 9 equals
7.
7 is your b. So now, when we did this earlier, I told you you're going to plug into y equals mx plus b 2 times. This was the first time. Now, when we plug into y equals mx plus b,
What's the answer?
we're going to be writing our final answer. So
So
you
it's
have
going to be
y
y
equals,
equals -3
okay, your m is still -3,
plus 7, which is
x,
b.
and then your b you just found is 7. So your equation, y equals 3x plus 7. Yes, ma'am.
So this will look for
Okay, for number 7, they've given us the equation, -6x plus 3y equals,
-9.
oh my, -9, okay. And then our point is -1,5. So the first thing we need to do here is figure out the slope for the line that they've already given us. So we have to take this equation,
Are we going to move the 3y or?
we're going to take this whole equation right here, and we're going to rewrite it, remember?
Yeah,
You're
so
going to
it's
write
gonna be
it so it's in
positive
slope
6.
intercept form.
3y equals 6x plus -.
Okay, hold on. Let me rewrite that whole problem and then we'll start from scratch and work it, okay? No. What I'm gonna do first is start with this equation and rewrite it into slope intercept form. That way I'll be able to tell what that slope is. Okay, so I've got the -6x plus 3y equals -9. Okay, so first step here is to do what?
Get y by itself.
Add the 6x, so we're gonna get y by itself. So you have 3y equals a positive 6x minus 9. What do we do now? Divide everything by 3. Now, when I divide everything by 3, I end up with y equals 2x minus 3. Now, based on that, it's now in slope-intercept form. What is the slope for that line now? Not 2x, just 2. So your slope here is equal to 2.
That was light work, STS.
So that means a line parallel to that is going to have what kind of slope?
I have.
It's going to have a slope of 2 as well.
Oh, nigga.
Okay, so parallel lines are also going to have a slope of 2. Now, we've got our slope that we're going to use. Slope will be 2. The point we're going through is negative 1, 5. So I'm going to go ahead and label this with x and y, because now I'm going to plug this x, this y, and this slope into y equals mx plus b. Is everybody clear on that much? Okay. Okay, y equals mx plus b. Now, what is my y for this equation? So 5 equals, what is m? What is x? Okay, so 5 equals 2 times negative 1 plus b. 5 equals negative 2 plus b. What do I do now? Okay, add 2 and you have 7 equals b. Okay, so now I know what my y-intercept is going to be. So I'm at the last step. This time I'm plugging in one more time, but I'm plugging in with the new b I just found right here. And I'm going to use the slope that I found over here. So final step, y equals mx plus b. Y equals, what did you say the m is?
2.
So 2x, and what is b?
7.
So your equation, y equals 2x plus 7. Everybody clear? Okay. Shall we do number 8?
Yes.
All right. For number 8, these are asking you for the equation of the perpendicular bisector. Well, the key thing you have to remember about perpendicular bisectors is that they're going to do 2 things. Perpendicular bisectors are, number 1, going to intersect the new segment, the original segment rather, at the midpoint, and is going to divide it into 2 congruent segments. So that's the first part. The second thing a perpendicular bisector does is it's going to make right angles when it intersects the line. So, you have segment ST here. Since it's horizontal, you know that if it's going to be bisected by the perpendicular, excuse me, by the perpendicular bisector, that it's going to make a perpendicular segment going this way. So, based on that, what is the slope for this line?
0.
This slope is 0.
How you know it's 0?
Because it's horizontal. Anytime you have a horizontal line, it's always got a slope of 0.
What is perpendicular?
If it's perpendicular, what is that?
0.
It's undefined. Remember we talked about that? I drew those graphs up here. If it's a horizontal line, there is no slope because there's no rise.
The inverse of 0 would be 0.
Undefined. If it's a perpendicular line, the slope will be undefined. Okay? We talked about that before. Vertical lines have no slope. They're undefined. It's just a straight drop down. Remember, a slope is a slant. How slanted is it? If it's horizontal, there is no slope. It's like your floor. It shouldn't be sloped. That's a 0. If it's vertical, your slope doesn't exist either because it's just a straight drop. Okay, so that would be undefined. Now, in this case, we do need the midpoint. We can get the midpoint of this line by either counting halfway or adding the x's and dividing by 2, and then adding the y's and dividing by 2. Let's do the midpoint. All right, so the coordinate for this point S is, let's see, let's do t first. T is at -1, +1. And then my point S is going to be 6, 7, 8, 1. Okay, so to get the coordinate for that midpoint, you're gonna add your x's and divide them by 2, add your y's and divide by 2. Now, when I add the x's, I have 8 plus -1. Stop listening. Divided by 2. Add the y's, 1 plus 1. Divided by 2.
Mr. Yes. The H supposed to
Thank you, thank you, thank you.
Yeah.
Thank you for that. Okay, so -8 plus -1 divided by 2. -8 plus -1 is
Negative
-9.
9
And what
divided
is
by 2.
-9 divided by 2?
Like 4.
Okay, so that's gonna be a -4.5. All right, then do the same thing for your y's. 1 plus 1 is 2 divided by 2. So, okay, 2 divided by 2 becomes your 1. So the coordinate for this midpoint will be at -4.5, 1. So that's right around here. -4.51. Okay, yes. This is the formula for a midpoint, so yes.
Wow,
You
I
just
really
add your
could've just
x's
did
and
this
divide
by
them by 2,
counting.
add your y's and divide by 2. That's all you do when you're finding the midpoint. If they ask for a midpoint, yes, -4.5 is -4.5, right?
So there is no formula. I mean, equation. No, like the y.
Oh, we haven't finished. I'm not finished yet. Yeah.
Oh, I think
Yeah.
you're done.
Oh, no, we're not done. Okay, so what we know is this. We know the midpoint is here, and they're asking for the perpendicular bisector. So what we're essentially gonna have is, we know we're gonna have a perpendicular line, but it has to go through the midpoint. That, otherwise it's not bisecting the segment. So I can actually draw that line. And it's just gonna be right here. There's your line. This is the perpendicular bisector of that segment. Now the key is, it's not gonna cross the y-axis. It's not, because it's vertical. So when you have a straight vertical line, the equation for that line is always x equals wherever it crosses the x-axis. Where does this cross the x-axis?
4.5. 4.5.
What kind of 4.5?
Negative.
That's -4.5, so x equals -4.5. That's your equation for this perpendicular bisector. And that's only because you started out with a horizontal line. And so when you write your equation, it's got to be the equation of a vertical line. Vertical lines are x equals whatever number it crosses the x-axis at. Okay? Now, if we do number 9, that problem's a little bit more like what you're used to seeing. Let's work it out. Again, it's supposed to cross at the perpendicular bisector. And this one, if you haven't, put a star on this one, because this one you definitely need to understand, okay? You know when I tell you to put a star, what that usually means is that you're gonna see it again. Okay, so here, we need 2 things. We need the slope, and we need the point that it's supposed to go through. Well, if it's going through the perpendicular if I'm making a perpendicular bisector, then I know that the new line has to go through the midpoint. So I need the coordinate for the midpoint here. Let's go ahead and find the midpoint. We need the coordinate for point G and F. What is the coordinate for G?
-1, 1. Negative. No, 1, -1.
Okay, so 1, -1. That's the coordinate for G. Now F, where's that?
6,
7, 3.
7.
7, 3. Wait a minute, yeah, 7, 3.
No,
G is at 1, -1, F is at 7, 3.
It
Let's
is.
see, can you do this in your head? You ready? For the midpoint, you know you're gonna add your x's and divide them by 2, Add your y's and divide by 2. So here, if I add my x's, 1 plus 7 is,
8, 4.
okay, let's try that again.
It's 8.
1 plus 7 is,
It's 8 divided by 2 is
and
4.
8 divided by 2 is 4. So, there, that's the first part of your midpoint. Then do the same thing with the y's. Negative 1 plus 3 is
2,
2 divided by 2.
1, so it's 4, 1.
So your midpoint is at 4, 1. Stop it. Your midpoint is going to be at 4, 1. And that's right here. So what we know now is that we got the point that the line has to go through. That's going to happen to be your midpoint. And we still need to get the slope for this line. You can get the slope by using the slope formula, or you can count. I'm going to count because it's faster.
The formula is better.
So to get your slope, slope is rise over run. So I'm going to start with point G, and I'm going to count over here to point M. What is my rise from G to M? It's 2. Well, the rise is 2. And then my run will be 1, 2, 3. So the slope for line GF is 2/3. And that's nice, but they want the equation of a perpendicular bisector.
So it's going to be upside down. So it'll be negative 3, 2.
Whatever.
Negative 3 halves.
Thank you. So your perpendicular slope will be the negative reciprocal of the 2/3. So it'll be a negative 3 halves. Okay, so your midpoint is at 4, 1. And the perpendicular slope is negative 3, 2.
Do you use the mid? Is it the midpoint or using to use the slope formula? Or?
So, I'm sorry, repeat.
Never mind.
You sure?
Yeah, we don't need
Okay, so we got our midpoint, that's gonna be the point that we use, and we got our slope. So now we're gonna do the same thing we did in those other equations with the y equals mx plus b. Okay, so y equals mx plus b. What is my y?
Your y is
One.
My y is 1. Come over here with the midpoint. Okay, y is 1. What is my m?
No, that's X. We don't know M.
Yes, you do. You
It's
do.
two. Oh,
negative 3 over 2.
It's the negative 3 over 2.
the slope.
Right. So your slope is the perpendicular slope, so it's negative 3 over 2.
Times 4.
Now, what is my x?
4.
Plus b. So 1 equals negative 3 halves times 4 plus b. 1 equals. Now, we're going to multiply here. What is negative 3 times 4?
12.
What kind of 12?
Negative 12.
And what is negative 12 divided by 2?
6.
Come on, watch your time. What is
Negative
negative
6.
12
Negative
divided by
6.
6? Negative 6
Whoa, what is this?
plus b. Let me go back again. You ready? Okay.
I'm over here multiplying.
Yeah, that's what we do. Okay, so we're doing this one more time, the multiplication part right here. Negative 3 times 4 is
Negative 12.
negative 12. And then this negative 12 divided by 2 equals right here.
I thought you had to do the scratch work.
You can.
I mean, I was finna get.
Okay, so we're gonna do number 17. Number 17 is asking us to find the perimeter and the area for the quadrilateral. So I taught you a couple different ways you can do it. I said that to find the area, you know, you can count the squares. However, a much more accurate way of finding the area here would be to draw the rectangle around the entire quadrilateral, then find the area for it. Austin, I'm trying to teach you. Could you stop? Thank you. So first thing I told you to do was you could draw the rectangle around the entire quadrilateral and then find the area for the triangles that you get as a result of your rectangle that you're going to draw and subtract those out. So let's do that first and then we'll come back and do the perimeter. So first step, make your rectangle. There. Now once you draw that rectangle, we want to go ahead and find the area for the rectangle. Now, the area for this entire rectangle is gonna be length times width, so you can count across the bottom, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. And then from the top to bottom is 1, 2, 3, 4, 5, 6. So to find the area for the rectangle, it's gonna, the area of the rectangle is gonna be 9 times 6, which is 54 square units. Okay, so that's gonna be the area for the yellow rectangle that we just drew. But once you drew that rectangle, if you notice, you've got now 3 triangles in here. This is triangle A, B, and triangle C. So what we're gonna do now is find the area for each of those triangles. Once we have the area for each of the triangles, we're gonna subtract all the triangles areas from the area of the rectangle. So let's find the area for triangle A now. Now you know the area is 1/2 base times height. So since these are right triangles, for triangle A, you've got a height of what? So that height is 2. What is the length across the top here? It should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So for that triangle, you've got 2 times 9, and you're going to divide that in half. 2 times 9 is 18. Half of 18 is 9. So the area for triangle A will be 9. Then you're going to do the same thing for triangle B. Okay, so for triangle B, what is this length across the bottom?
Oh, no, 3.
Okay, down here is 3. And then you have a height from the bottom up to this point is 1, 2, 3, 4. So for that triangle, it's going to be 1/2, 3 times 4. Well, 3 times 4 is 12. Half of that, 6. Okay, so B has an area of 6. We do the same thing for C. All right, so for triangle C, you have a distance across the bottom of 1, 2, 3, 4, 5, 6. And then you've got a height over here of 1, 2, 3. So 1/2, 6 times 3. 6 times 3 is 18. Half of that is 9. Now, your 3 triangles, if you add the 3 triangles together, what do they add up to? 18 plus 6 is 24. So the triangles have a combined area of 24. To get the area for the whole thing, your total area will be 54 minus 24, which is 30. So the area for that quadrilateral is 30 square units. Yes, ma'am.
I do the distance from, like.
Okay, now if you do the distance formula, that'll give you the perimeter, but the distance formula won't give you the area. Okay. All right, so is everybody clear on how to find the area? All right, so next we still need to find the perimeter. They did ask for the perimeter. Now the process that we use to find the perimeter here is the exact same process you can use to find the perimeter up here on number 16 and down here on number 18. Now, the easiest way, in my opinion at least, the easiest way to do it is to use the Pythagorean theorem. You could do the distance formula, that's fine, it'll work too, but I prefer the Pythagorean theorem. So, let's see what color I can use here. Let's see. What if I do this green right here? Okay, we'll use that. Okay, so now, I need to find the length of every side in that quadrilateral. Now, you may not be able to see it because I've highlighted over it a little bit, but segment HG is still a part of that quadrilateral. What's the length of that segment right here? This segment is 3 units long. So I'm gonna circle that, 3. Now I need to find the length of all the other slanted sides. And the easiest way to do it is with the Pythagorean theorem. So, based on what I already have, to find the length of this diagonal up here with triangle A, I'm gonna do 2 squared plus 9 squared equals segment HE squared. So 2 squared is 4, 9 squared is 81, equals HE squared. That's gonna be 85. And then we're gonna take the square root of that. So we need the square root of 85. And you said it's about 9.2? Okay. So HE is approximately 9.2. Okay. So we've got those two sides. So now we need to find the length of segment EF. So to get the length of EF, that's another Pythagorean theorem. You've got 4 here, 3 here. Does anybody off the top of your head know what that should be? It's a Pythagorean triple. 16 plus 9 is? Let's write it out. You'll have 3 squared plus 4 squared equals FE squared. So that's 9 plus 16. Add. And FE is equal to 5. Let me erase that out. Okay, so FE is 5. So now we only have one more side to find, and that's going to be segment GF. Let's see if I can squeeze that in here. So we've got the dimensions for 3 and 6 down here, and we'll use GF as our hypotenuse. So 3 squared plus 6 squared equals GF squared. 9 plus 36 is GF squared, that's 45. Okay, can you take the square root of 45 for me? 6.7, thank you. Okay, so GF is 6.7. Now, you can get the perimeter, now that you know what all 4 of the sides are. We just did the Pythagorean theorem really quickly for the 3 slanted sides, but add all 4 sides together. The 3 plus 9.2 plus 5 plus 6.7, and what do you get?
I mean, like, 23.9.
23.9? Okay, so 23.9 units is your perimeter. Okay, for number 24, the problem says a rectangular cornfield yielded 2,200,000 ears of corn. The dimensions of the cornfield are 800 yards by 550 yards. And they ask us how many ears of corn per square yard did the cornfield yield. All right, so this is a population density problem. And the formula for population density means the number of items population density is equal to the number of items divided by the area. So with that being said, I already know the number of items. What I need for me to be able to plug into the formula is the actual area of the region that we're working with. So to get the area, I'm going to take the dimensions they gave me for the cornfield, the 800 yards by 550 yards. And I know that's what I need because they told me that this is a rectangular cornfield. So area for a rectangle is length times width. So my length is 800 yards. And the width is 550.
So let's multiply that. So 800 times 550.
All right, what do you get when you do the 800 times 550?
1,000.
Okay, so 440,000 square yards. Okay, 440,000 square yards is our area. Now, to find the the population density, so the number of items is, right, the 2,200,000
Over 440,000.
divided by 440,000. Okay, so divide that out. The 2,200,000 ears of corn divided by the 440,000, and you get 5.
That's crazy.
So 5 ears of corn per square yard is your answer there.
I like the one that's here.
You want it like that?
No, not all of them.
Yeah.
Now, the other one that's like that one would be number 26. Did anybody ask about 25 or no? All right, let's go ahead and do 25. So the density equals mass divided by the volume. So in this problem, it says you got a hot air balloon and it's gonna hold 74,000 cubic meters of helium. So that keyword, what's the keyword there that lets you know where you're gonna put that? The cubic meters. So if you have, y'all let me know when you're ready. I'll wait. It's not like y'all have a test tomorrow. I'll just wait. Take those headphones out. All right, so the key word is holds and then cubic meters. Remember, if something is being held or if something can hold something, that's your volume. So you know your volume for this problem is going to be the 74,000 cubic meters. Let's set the proportion up. Okay, so there's 74,000 cubic meters. Next thing. They then told us that the gas has a density of 0.1785 kilograms per cubic meter. Well, they're giving us the density. You know that goes on the left side. So the 0.1785 kilograms per cubic meter. And they're asking how many kilograms of helium does the balloon contain? So your X goes up here, and yes, you are going to cross multiply. If you cross multiply, you're going to do the 0.1785 times 74,000, and that will give you 13,209 kilograms times meters cubed equals X times meters cubed. Because again, you are cross multiplying. And when I cross multiply here, I have the X times the meters cubed. When I cross multiply here, you have the number, which is the 13,209, and you can't forget your units, kilograms and cubic meters. Now, I want X by itself. What do you have to do to get the X by itself? Divide by what? This is where I am right here. I want the X by itself, what do I do?
Or just put in 13.
Right, divide both sides by the cubic meters, right?
So where just go all in.
The meters cancel here and here, and you're left with your final answer of 13,209 kilograms equals X. Okay. All right, let's go ahead and do 26. Now, in number 26, you got to do a little bit of work before you can get the final answer here. They've given you what you need to figure out the area. What is the area going to be? It says there are 6 rocks per 7 meter by 5 meter section of a yard. And then they're asking if the yard is 780 square meters, what is the appropriate number of rocks in the yard? So your area will be 35 meters squared. And now they're asking for the number of rocks. So if you take what they started us with at the beginning, they said that you're going to have 6 rocks. And those 6 rocks are contained in a 35 square meter section of the yard. And then they're saying that the yard is 780 square meters. So that means I need to, I need to set up a proportion, right? So if I want to get rid of,
Put it off the top.
hold on a second, hold on. Okay. Okay. I want to know how many rocks are going to be left. So I'm going to put the meter squared up here. And 780. So what's going to happen with these units? Cancel the meters. And then you multiply straight across the top. 6 times 780, that's 4,680 rocks. Divided by the 35. And that will equal 133.7 rocks. You can put that over one if it's confusing for you to have it or not. All right, so you asked for number 27 also? Yes, sir. Hold on one second, let me turn this thing off. Okay, for number 27, this problem is going to require you to do several of these with the stoichiometry, dimensional analysis type of problem. That's what this is. So you're going to have to do quite a bit of conversions here. So it starts off by telling us that we have 286 ears of corn in a 10-foot by 15-foot portion of a cornfield. So you already know this is going to be used to give you what? The area. You can talk. It's okay. It's going to be used to give you the area. So your area is going to be 10 by 15. Which is 150 square feet. Then the next thing, if the farm consists of 3 acres of cornfields, how much corn can we expect to produce? And then they give you a conversion from acres to square feet. Okay, so let's set up what we have. We know from the beginning that we're going to have 286 ears of corn. And those 286 ears of corn are going to be contained in 150 square feet of land. Why would the what be on top? Because that's how many ears of corn we have. So remember, the formula for population density is the number of items divided by area. So this is my number of items. And this 150 square feet is my area. Okay? Now, all right, here's the next thing. They said that this is how many acres of land?
3 acres.
We have 3 acres. But that's a problem because the question is asking me, how much corn can they expect to produce? Right now, I can't cancel any of my units. So I've got to figure out how I can cancel the units. So then I look at this conversion factor that they gave me over here. That's important. So to finish this thing up, as far as setting up the problem, I have acres on the top, and I need to get rid of acres. Where's acres going to be in this next piece of my equation? Where is it? It's got to go on the bottom. So I'm going to take this 1 acre from the conversion, 1 acre, and put it on the bottom. Now that 1 acre is equivalent to how many square feet? Okay, 43,560 square feet. Now, if you look at this, it works out the way we need it to, because when we start canceling out units, I've got square feet on the bottom here, and then I have it over here on the top. It cancels out. Then I've got acres on the top here, and acres on the bottom here. So the question, when I'm done, it's supposed to tell how many ears of corn should they expect to produce. The only unit I have left is the number of ears of corn. So I know I've got everything set up right now, I just need to work it out. So if you multiply straight across the top, and then multiply across the bottom, on the top, you're going to get, actually go ahead and multiply on the top, because I don't have it written out on with that. What do I get if I multiply on the top? I'm sorry, would you read it again? Okay, hold on. 3787. Okay, so 37374486 ears. 80. And then on the bottom, I just have 150. Okay, if you go ahead and divide the top by 150, what do you have? You should have 249,163.2 ears of corn. Okay. Yes, ma'am.
What if you just, what if you just, added 43,563 times?
I mean, you could, it's the same as multiplying by 3. Okay, hang on 1 second.